We are diving into the world of unified modeling language, specifically focusing on activity diagrams. These powerful visual tools help us map out complex workflows, ensuring clarity and efficiency in system design. Activity diagrams model dynamic system behavior by showing workflows. They are essential for visualizing sequences of actions, decision points, and parallel processes within a business context. Activity diagrams sit within the behavioral category of UML. Understanding this hierarchy helps us select the right tool for modeling specific system aspects, distinguishing structure from behavior. UML diagrams are divided into structural and behavioral categories. Activity diagrams belong to behavioral diagrams, focusing on the flow of control rather than static system architecture. Behavioral diagrams include activity, use case, and state machine types. Activity diagrams specifically handle complex workflows and concurrent operations within a system. Choosing the correct diagram type depends on whether you need to show static relationships or dynamic interactions. Activity diagrams excel at showing processes. Let us explore how to model simple workflows using basic activity diagram elements. We start with a word processor example to understand sequential actions and decision points. Sequential actions are represented by rounded rectangles connected by control flows. This simple structure allows us to define the exact order of operations in a process. Decision diamonds introduce branching logic based on conditions. This allows the workflow to follow different paths depending on specific criteria or user inputs. Fork and join bars enable parallel execution of activities. This is crucial for modeling tasks that can happen simultaneously without waiting for each other. We now apply these concepts to real world scenarios like order processing and student enrollment. These examples demonstrate how diagrams handle complex business logic effectively. Order fulfillment involves multiple departments and parallel steps. A diagram clarifies how payment verification and inventory checks happen simultaneously to speed up delivery. University enrollment requires form validation and multiple steps. Swim lanes help assign responsibilities to the registrar and the student clearly throughout the process. Both examples include paths for errors or exceptions. This ensures the workflow accounts for real world issues like invalid forms or payment failures. Swim lanes group activities by actor or department. This visual separation clarifies ownership and handoffs between different roles within a complex system workflow. Swim lanes are vertical or horizontal partitions that group related activities. They visually separate responsibilities, making it clear who performs each specific task. Without swim lanes, all activities appear in one flow. This can make it difficult to identify which actor is responsible for a specific action in the diagram. With swim lanes, the diagram becomes a matrix of roles and tasks. This structure highlights handoffs and ensures accountability across different departments or systems. Understanding the basic symbols is crucial for reading and creating diagrams. We will examine the activity, action, and control flow notations used in UML. An activity is represented by a rounded rectangle. It signifies a set of actions or a high level process step within the overall workflow diagram. An action is a specific task to be performed. It is also shown as a rounded rectangle, but represents a single atomic operation within the flow. Control flow is shown as a solid arrow. It indicates the sequence of execution, showing how one activity transitions to the next in the process. Every workflow needs a clear beginning and end. We will look at the initial node, final node, and decision node notations to define flow boundaries. The initial node is a filled black circle. It marks the exact starting point where the activity or workflow begins execution within the system. The final node is a black circle with a border. It signifies the termination of all control flows and object flows in the activity diagram. A decision node is a diamond shape. It represents a test condition where the flow branches into different paths based on a Boolean guard condition. Advanced diagrams use fork, join, and swim lanes to manage complexity. These elements allow us to model parallel processing and group activities by actor effectively. A fork node splits behavior into parallel flows. It allows multiple activities to execute simultaneously, increasing efficiency in complex system processes. A join node brings parallel flows back together. It ensures that all concurrent activities complete before the process continues to the next step. Partitions group activities performed by the same actor. This helps organize the diagram logically and clarifies which role is responsible for each activity. Now we move to practical implementation using visual paradigm. We will start by creating a new diagram and naming it for our project. Click the new button in the toolbar to start. Select Activity Diagram from the list to initialize a fresh canvas for your workflow modeling. Name the diagram clearly to identify it later. This helps in managing multiple diagrams within a larger project or system documentation set. The empty diagram appears ready for elements. You can now begin adding swim lanes and nodes to define your specific business process workflow. Next, we organize the diagram with swim lanes. This step assigns roles to specific sections of the workflow for better clarity and accountability. Select the vertical swim lane tool from the menu. Click on the empty canvas to create a partition for a specific actor or department. Double-click the partition name to rename it. This ensures every swim lane clearly identifies the responsible role, such as customer or sales. Place the initial node in the starting swim lane. This marks where the workflow begins for the specific actor responsible for the first action. We now add the core elements of the workflow. Activities, decision nodes, and final nodes are dragged onto the canvas to build the process. Drag an action from the resource catalog to the canvas. Connect it to the initial node using a control flow to start the sequence. Add a decision node to introduce branching logic. Connect it to actions to create conditional paths based on specific criteria or user choices. Place the final node at the end of the workflow. This marks the completion point where all parallel flows converge and the process terminates. Once complete, review the entire diagram for accuracy. Ensure all paths lead to a final node and swim lanes correctly reflect responsibilities. Check that every decision has a valid path. Ensure no activity is left hanging without a connection to the next logical step in the flow. Verify that swim lanes clearly separate responsibilities. This makes the diagram easier to read and understand for all stakeholders involved in the process. Save the diagram as a living document. It serves as a reference for training, development, and future process improvements within the organization. Activity diagrams are vital for visualizing complex workflows. They improve communication, reduce errors, and streamline processes across different departments and systems. Diagrams provide a clear visual representation of processes. This helps stakeholders understand complex logic without needing to read lengthy technical documentation. Mapping workflows helps identify potential bottlenecks early. This proactive approach reduces errors and improves overall system efficiency and reliability significantly. The diagrams serve as excellent training materials for new employees. They provide a visual guide to standard operating procedures and system interactions. Thank you for joining this comprehensive guide to UML activity diagrams. We hope this presentation has equipped you with the knowledge to model your workflows effectively.